Welcome back, dear students. For today's class we are going to see the numerical on losses due to friction. So you can see the question here. A concrete beam of 10 meters span and 100 meter wide and 300 mm depth is prestressed by 3 cables. So it is 10 meter length and cross section I can write it as 100 by 300 mm. Neutral axis being at the center. The area of each cable for each cable is 200 mm square, and the initial stress in the cable P0, small p0, is equal to 1200 Newton per mm square. Cable 1 is parabolic with an eccentricity of 50 mm above the centroid at the supports. So if I am drawing cable 1, it is 50 mm above the center of the support, that is, it is 50 mm somewhere here, and 50 mm below the center of the span. So which means it is coming, center of the span is coming like this. So the cable is going like this. One cable is like this. This is cable 1, and cable 2 is also parabolic with 0 eccentricity at the support. Cable 2 is having 0 eccentricity at the support and 50 mm below the centroid at the center of the span. That is, this is going like this. Now cable 3 is a straight, the uniform eccentricity of 50 mm below the centroid, which means this is a straight line. This is a straight with 50 mm eccentricity. This is cable 2 and this is 3. If the cables are tensioned from one end only, that is, we are tensioning it from one end, which means this is being anchored over here, this is anchored over here, this is anchored over here, and this is anchored over here, and we are applying the tension from this end. Estimate the percentage loss in stress due to friction. So this is going to have a loss due to friction. So we are going to find what is the loss due to friction. So first we need to understand what is the basic formula for finding the loss due to friction. So if you come to your code, you can see here your IS code specifies the loss of pre-stress due to friction in clause number 19.5.2.6. For straight or moderately curved structures with curved or straight cables, the value of pre-stressing force Px is the value of pre-stressing force at a distance x from the tensioning end and acting in the direction of the tangent to the curve of the cable shall be calculated as. So this gives you the value of pre-stressing force at the end. So P0 is the initial pre-stressing force, alpha is the cumulative angle in radians, mu is the coefficient of friction curve, that is your due to the curvature effect, coefficient of friction due to wave effect K, and this mu and K value you can get it from the next page of your IS 1343/2012 based on the type of steel provided, but in this question it is directly given. Otherwise in the question it will be given which type of cables we are using and what material it is made of, the duct is made of. So mu and K you can get it from here. Now the unknown values in this equation are Px, which is need to be found out, and alpha and x value. So I'll explain that here, how to find the value for alpha and x. So you consider as a general note, you have a beam like this and it is having a parabolic, parabolic tendon like this. The general equation of this beam, this curve, I can write it as, we have studied the general equation of the parabola, that is equation of a parabola. We have studied 4hx by L square into L minus x, where h is the distance from the centroidal axis. So I can write this as 4ex by L square into L minus x, both are same. So here the equation of the parabola, I can write y is equal to this is equation. So which means I can write this is the equation of the parabola at any distance y. So I can write the slope theta is equal to, when theta is very small, I could write it as tan theta is equal to dy by dx is equal to 4ex by L square and L minus x of dy by dx of this value. So I'll get this as 4e by L square into L minus 2x, that is the dy by dx. So this is the general equation, deflection or equation of the parabola at an end, and this corresponding slope or theta at any point corresponding to x. So there are two cases, that is case 1 when jacking from one edge. When jacking from one edge, case 1, that is, we will be jacking it over here we will be jacking it over here and we'll be applying the pre-stressing force from here. So the maximum loss will be occurring here, right? At this end will be the maximum loss due to friction. So x is equal to L here when jacking from one edge. That is where the maximum loss occurs. So if I am taking, now we need to find the value for alpha. Alpha is a cumulative angle, that is you have the slope here as suppose theta, and here also the slope at this point is theta. So here alpha means the cumulative angle between these two, that is alpha is equal to the angle between these two. Now we'll get this as 2 theta. So in general I can write, when this is being jacked, the jacking is provided only from one edge, then I can write x is equal to L and alpha is equal to 2 theta. Now if I am substituting this value here, then I can write alpha is equal to 2 theta, that is alpha is equal to 2 into theta is what? 4 e by L square into L minus 2x. So here x is equal to L, so I can write this value as 2 into 4 e by L square into L minus 2L, that is minus L. But this minus just signifies the direction, that's all for this alpha. So I can write this one as 8. You don't need to consider the minus sign, that is in order to determine the direction. So you can write it as 8 e by L, that is in radians. So this is the case when it is jacking from one edge. Now when the same thing happens, or when it is jacked from both the ends, case 2, jacking from both the ends. So here it will be similar to, here we will be applying force from this end as well as this end. So the maximum loss will be occurring at the midspan. So I can write x is equal to L by 2 if it is jacking from both the ends, and value for theta, this is actually going like this. This is theta, and this value, this is a cumulative angle. So this alpha is equal to theta here. So I could write in general x is equal to L by 2 and theta is equal to, alpha is equal to theta when it is jacking from both the ends. So I can write alpha is equal to half of this value, that is equal to 4 e by L in radians. So these are the two things you need to understand to find the value for alpha and theta, sorry, x and alpha. So now based on this understanding of your, that is just need to understand these two, and now we will come to do this numerical. We have seen here we need to find the slope at both the ends. So slope at both the ends, that is alpha is equal to, I could write, so I can write here for cable 1 alpha is equal to, for cable 1 alpha is equal to, we have this in the question, it is given, it is tension if the cables are tensioned from one end only. If it is tensioned from one end only, that is a case 1, which means alpha is equal to 8 e by L in radians and x is equal to L. So based on that understanding, we will write alpha is equal to 8 e by L, alpha is equal to 8 e by L. Here E is what? E is the distance of your, we are considering at the end, the loss at the end, because in this equation it is given Px at a distance x meters from the value of resisting force at a distance x meter from the tensioning end and acting in the direction of the tangent. So here we are considering at the end for cable 1 alpha at the end, we are considering is equal to 8 e by L. E here is what? At the ends, if I am considering the distance of your parabola from the centroid is from here 50 plus 50, that is 8 into 100 divided by L is 10 meter into, we are converting this into millimeter, so you will get this as 0.08 radians. And for cable 1 I have the value for alpha as 8 e by L, that is this value. Now for cable 2 cable 2 I have alpha is equal to 8E by L. Here for cable 2, E is what? From here to here, that is 50 mm. 8 into 50 divided by 10 into 100,000, sorry, that is 0.04 radians. And for cable 3, we don't have any alpha value because it's a straight cable. So for cable 3 alpha is equal to 0. So we had found the value for alpha. Now you have the equation for finding the value for Px, that is the total pre-stressing force at the end given as Px. So if I am writing here, Px is equal to P naught into e raised mu alpha plus kx, that the free end. For small values of mu alpha plus kx, if I am expanding this e raised to minus, I could write it as this one is equal to P naught into, if I am expanding e raised to x, if I am expanding, I will get it as 1 minus mu alpha plus kx. I could write for small values of e raised to x, I can write ex is equal to x is equal to 1 minus this one. That is, this Px value is P naught into 1 minus mu alpha plus kx for small values of mu alpha plus kx. So this is Px value, that is the pre-stressing force at the end. So the loss in pre-stressing force, I could write the loss of pre-stress due to friction, I could write as PL, which is equal to initial force, that is P naught minus Px, isn't it? P naught minus Px, that is, I could write this one as, this is equal to P naught minus Px, I could write it as P naught into 1 minus mu alpha plus kx. So when you expand this, you will get this value as P naught into mu alpha plus kx. You will get this value like this, that is P naught into mu alpha plus kx. That is, I could write it as the total loss of pre-stress PL is equal to P naught into mu alpha plus kx. Either by heart this value, or you can come to this value from this. So here, now we will go to the loss in pre-stress. You know the value for alpha, you know the value for x, mu and k and P naught. So we will find the loss in each cable due to this value, that is the loss in pre-stress in cable 1. Loss in stress in cable 1 is equal to P naught into mu alpha plus kx. So P naught is given as, we need to find the value for P naught. P naught for each cable, is 200 into 1200, that is 240 kilonewton per cable. So I can write this one as, I will just denote it as P naught itself for your easy calculation, that is P naught into mu, given in the question itself, mu is equal to 0.035, mu is given as 0.35, that is 0.35. Alpha for cable 1 is 0.08 radians, 0.08 plus k it is given in the question as 0.0015 per meter. So I can write as 0.0015 into, its unit is meter, so I will not convert the x value. X here is jacking from one end, so x is equal to L, and I will write it in meters itself. So this value you will get it as 0.043 P naught. So that is the loss in stress in cable 1. So the percentage of loss, I could write it as the loss in stress, that is 0.043 P naught divided by the total initial stress, that is P naught, into 100, which means I will get this value as 4.3%. Similarly, if I am doing for cable number 2, that is loss in stress for cable 2, that is P naught into mu alpha plus kx. Here P naught is same, mu I could write as 0.35 into alpha. Alpha here is for cable 2, alpha here is 0.08, not 4. plus 0.0015. K is same and X is also same. So here this value I'll get it as 0.029 P0, which means I could write the percentage loss in stress as percentage loss in stress is equal to 0.029 P0 divided by P0 into 100, that is 2.9 percentage. Similarly for cable 3 I can write it as cable 3 generate as P0 into mu alpha plus Kx. Here alpha is 0 since this is straight pre-stressing cable, that is P0 into alpha 0.0015 into K10, X is 10, that is I'll get this value as 0.015 P0. So the loss, corresponding loss in cable 3 I could write it as 0.015 P0 divided by P0, that is into 100, that is 1.5 percentage. So that is your loss due to friction. So we will do one. I'll give you. So that is your loss due to friction. I'll give you one more question for this loss due to friction. You can solve by yourself. Thank you.